Each year during Christmas I allow myself to work on a little side project just for myself, and this year I made this pair of over-engineered compasses. I always thought it's not that elegant that the tips usually spread out at an angle, limiting the usable range and also leaving a slightly messed up hole in the paper for larger diameters. I also know there are some types where you can angle the tips manually, but I wanted to keep them straight by design. It all started with these laser cut parts from 1.5mm brass sheet metal, which I had ordered years ago with a bunch of other parts I needed back then. Laser cutting always leaves rough, uneven edges, so the first step was to sand them smooth. On curvy edges I'm using these small abrasive rubber wheels for my Dremel tool. Some extra care was needed for the teeth of the gears for them to mesh evenly. These will later force the compasses to always spread symmetrically. That's not perfect, but good enough for the purpose, I suppose. Gear cutting is still on my wishlist for now. Then I also sanded all parts evenly flat. To achieve a precise movement without any slop, I also reamed all holes, which will later form the individual linkages. And then continued to tap the threads for the wooden handles. Most of the design boils down to a sandwich of sheet metal parts, which basically form this linkage system necessary to keep the tips always straight. The distance between these tip plates is 1.5mm, and the lead and needle will both be 2mm thick. So my idea was to just form two grooves to act as clamps by carefully drilling into this precisely spaced sandwich of plates. Might not be the most elegant solution, but it worked well enough. The needle itself is made from silver steel. First I formed the rough shape on my lathe and then hardened it by heating and quenching. While in its hard state, I put it back onto the lathe and used a small grinding disc while having it rotate to form a nice sharp tip. Then some polishing with fine sandpaper. And finally I tempered it back to a light blue color. Here I'm turning the main handle of the compasses. This brass rod will be the core to a wooden sleeve, which gets added later. On the mill I formed these flat surfaces to make it fit the gap between the top plates precisely. The main handle will be made of dark walnut wood. But I only had some oddly shaped scrap pieces, so first step was to turn them into a cylinder on the lathe. Then I manually shaped the handle. But don't look too close, this was my first try at wood turning and I just figured things out on the fly. Luckily it worked out and the piece looked quite nice after oiling it. While being at it, I also turned some wooden knobs for the adjustment screws on the tips. There will be a square interface between a brass screw and the wood part, so the knob cannot rotate on its own. Sadly, I didn't record me making the brass parts, sorry. The outer legs of the compasses also get a few strips of wood to serve as dedicated place to touch them while handling it. After drilling and sinking the holes on the mill, I just cut the strips by hand. But I have screwed on an extra piece of laser cut brass which serves as guide for sawing and filing. This makes it so much easier to hit the right dimensions. Lastly, I had to figure out how to make nice looking, well-moving linkages to assemble everything. Threads on their own are not a nice bearing surface, so originally I wanted to insert some tiny pieces of precise tubing to serve as pins, with the screws going through the center. But I wasn't happy with the look of nuts on the backside either, so I finally decided to use 2 screws from both sides and put a tiny thread inside that pin to hold it together. So that's what you see me making here. The screws should also look really nice and blend in with the design, so I opted for hexagonal-headed steel screws. On their own they are quite ugly, but with a bit of polishing on the lathe, the head can easily be made super shiny. Then I carefully heated them until they turned a lovely dark blue color, which will contrast the yellow brass nicely. I love it. Finally, I gave all parts a nice shiny polish and added my hallmark. But of course I had to mess up on that very last step, and my sign ended up being upside down. Either way, everything was ready for assembly. But before revealing this most satisfying part of the project, a quick word from my sponsor. PCBWay is an easy-to-use service for manufacturing all sorts of technical components. Be it laser-cut sheet metal like I'm using here, CNC machining, 3D printing, or electronic circuit boards. Their service is always super easy to use. Just upload your design files on their website, select the material and techniques to use, and get an affordable instant quote ready for ordering. It's super nice to live in a world where industrial quality manufacturing techniques are so easily accessible with a few clicks. I'm using lots of laser-cut sheet metal components on my miniatures, and there is just no way to get this done on a hobby machine. Same goes for 3D printing tough materials or even metals, which I'm also using for armature construction when I need some oddly shaped parts, which would be a pain to make manually. If you wanna try it out yourself, you'll find a link to their website in my description down below. Huge thanks to PCBWay for the great service and for sponsoring my video. Now let's get back to the assembly of these lovely shiny bits and pieces. I can tell you it's extremely hard to do this while a camera is blocking your view, so pardon me for not being able to show all the details as precisely as we would like to see them. Now, let's give it a try. It works quite well, but I should sharpen the lead a bit better next time, sorry. But still, it's a real pleasure to use. I also secretly made two of them, one with normal pencil lead, the other with two hardened steel tips to scratch fine lines directly into metal. But when demonstrating this, I had the most slapstick accident with an exploding blue metal marker, so the footage I was able to get is really not optimal. Just imagine it producing much finer lines on a much thinner coated sheet. Or let's just do it without paint in the first place. If anyone would like to remake their own, I made my original plans available on Patreon, links in the description down below. And of course, things are never perfect on the first try, so this isn't either. And if I would remake it again, I would probably use slightly thicker material and make it a bit more stable, or maybe add a little cross connection between the two arms like most compasses have, because right now there's quite a bit of springiness in the system, or elasticity overall, which makes it a bit difficult to adjust to a precise size. If anyone comes around to it, I would love to see your improvements of this. I really enjoyed working on this small standalone side project, and it really feels good to finish something. Speaking of, you might wonder about the state of my main movie project or those miniature light controller boards I'm tinkering with. So I actually plan to make a live stream quite soon where I'll talk about all these things in a bit more detail, while maybe crafting a miniature version of those compasses you've just seen. So if you have any questions for me, be it technical or personal, then please leave a comment down below or write me a text. I'm really looking forward to it. Also, if you want to keep updated on my work, then please follow me on Patreon or subscribe to my newsletter, links in the description. Even non-paying free members always get a monthly update. Now, thanks again for watching, have a lovely day and see you next time again. Bye bye.